Hey everyone, and welcome to another deep dive. This time, we're tackling something pretty mind-blowing. Zero-point energy.
It's a topic that gets a lot of buzz, and for good reason. The idea of limitless, freely available energy is incredibly exciting.
Yeah, and today we're going to explore the science, the myths, and the real-world implications of this potentially revolutionary energy source.
We'll be diving into the work of experts like Dan Winter and Elizabeth Donovan, who are really pushing the boundaries of our understanding in this field.
Awesome. Now, before we get too far ahead of ourselves, let's define what we're actually talking about when we say zero-point energy.
Right, because it can sound a little esoteric. Basically, it's the idea that even in a perfect vacuum, at absolute zero temperature, there's still a residual amount of energy present.
Okay, so even in the seemingly emptiness of space, there's this underlying energy field just buzzing with potential.
Exactly. And that's where things get interesting. Because if we can figure out how to tap into that energy, well, the possibilities are pretty much endless.
So it's not just about creating new energy sources. It's about tapping into a source that already exists everywhere, all the time.
Precisely. And that brings us to Dan Winter and his work. He believes that the key to accessing zero-point energy lies in understanding a concept he calls imploding charge.
Imploding charge. That sounds pretty intense. Can you break that down for us a bit?
Sure. So imagine a whirlpool. As the water spins faster and faster toward the center, it creates this powerful vortex, right?
Yeah, I can picture that.
Well, Winter sees that vortex as an analogy for what happens with electrical charge. He argues that when charge flows in a specific fractal pattern, it creates a kind of implosion that generates a huge amount of energy.
Okay, so it's like creating a mini black hole of energy, but instead of sucking things in, it's radiating energy outward.
That's a pretty good way to visualize it. And the key to achieving this implosion, Winter says, is the golden ratio.
The golden ratio. Wait, isn't that mathematical concept you find in nature, like in the spirals of seashells and the arrangement of sunflower seeds?
Yep, that's the one. Winter believes that this ratio is fundamental to how energy flows in the universe. And when you apply it to the way electrical charge moves, you can create this incredible implosive effect.
So we're talking about harnessing the very geometry of the universe to unlock this hidden energy source.
That's the idea. And one of the most fascinating examples Winter uses to illustrate this principle is the humble pine cone.
A pine cone. Seriously?
I know, it sounds a little out there, but hear me out. Winter argues that the pine cone's spiral structure, which is based on the golden ratio, is a perfect example of how nature uses this principle to create and channel energy.
Okay, I'm intrigued. But how does a pine cone, just sitting there on the forest floor, actually demonstrate zero-point energy?
Well, for starters, pine cones have these high dielectric properties, meaning they can store electrical charge really efficiently.
So they're like little natural capacitors.
Exactly. And they also generate what's called a negative ion wind, which Winter sees as further evidence of their energetic potential.
Hold on, negative ion wind, like the stuff they sell air purifiers for.
The very same. And Winter argues that this wind is created by the pine cone's ability to tap into zero-point energy and convert it into a measurable physical phenomenon.
So we're not just talking about theoretical physics here. There are actual observable effects in nature that suggest this energy is real and potentially accessible.
Exactly. And that leads us to the question of whether the vacuum, what we traditionally think of as empty space, is truly empty at all.
Yeah, that's always kind of bugged me. I mean, if there's all this potential energy just waiting to be tapped, why haven't we figured it out yet?
That's a question that both Dan Winter and Elizabeth Donovan grapple with. And they both point to some pretty controversial figures who might hold some clues.
Oh, like who?
Well, Winter is quite critical of both Nikola Tesla and Albert Einstein, suggesting that while both were brilliant, they also made some crucial mistakes that hindered our understanding of zero-point energy.
Wait, Tesla and Einstein, those are like the titans of science. Are you saying they got things wrong?
That's what Winter argues. For instance, he believes Tesla's choice of 60 Hz frequency for our electrical grid was a misstep that doesn't align with the natural frequencies needed for optimal energy flow.
So he's saying our entire electrical system is out of sync with the natural world.
Yeah.
It's a pretty bold statement.
It is. And when it comes to Einstein, Winter critiques his concept of space-time, proposing that space is defined by charge, not the other way around.
So instead of gravity being the fundamental force shaping the universe, it's actually electromagnetism. That's a pretty huge paradigm shift.
It is, and it has significant implications for how we understand zero-point energy and its potential applications.
This is already blowing my mind. But you mentioned other examples of devices that might be tapping into this energy, right?
Oh, absolutely. And that's where things get really exciting, because we're not just talking about theoretical concepts anymore. We're talking about real-world devices and phenomena that suggest zero-point energy is more than just a pipe dream.
Okay, I'm on the edge of my seat. What are some of these devices?
Well, one of the most intriguing examples is the Bosnian pyramids.
Wait, pyramids? Like the ones in Egypt?
Not quite. The Bosnian pyramids are ancient structures in southeastern Europe, and according to researchers, they exhibit some pretty unique energy phenomena.
Like what? What kind of energy are we talking about?
Well, Patrick Boddy, a specialist in what's called life force measurement, found that the pyramid's power spectra closely resemble something called the Schumann resonance.
The Schumann resonance. I've heard that term before, but I'm not quite sure what it means. Can you refresh my memory?
Sure. It's basically a set of natural electromagnetic frequencies that are generated by lightning discharges within the Earth's atmosphere.
Okay, so it's like the Earth's own electromagnetic heartbeat.
You could say that.
Yeah.
And some believe that these frequencies have a profound effect on biological systems and global energy flow.
So are you saying that these pyramids are somehow amplifying or interacting with this natural energy field?
That's the idea. Dan Winter actually suggests that these pyramids might have been part of a global wireless power grid, a concept that Tesla himself was working on but couldn't quite crack.
Whoa. So we're talking about ancient civilizations potentially harnessing zero-point energy on a global scale. That's incredible.
So that's a pretty mind-blowing idea. And it leads us to some other examples of devices that might be tapping into this energy source, but in more modern contexts.
Okay, I'm hooked. Tell me more about these other devices.
All right, let's dive into something called the Joe cell. It's a device that claims to achieve what's called over-unity hydrolysis using concentric metal tubes and this thing called implosive capacitance.
Over unity. You mean it generates more energy than it uses. That sounds a bit like perpetual motion, which, as far as I know, is impossible.
It certainly challenges conventional physics, but that's the claim. The Joe cell supposedly splits water into hydrogen and oxygen with greater efficiency than traditional methods, hinting at an external energy source being tapped. And there are even accounts of this device being used to power a car. Wait, a car running on water? That's insane.
It is. But there's a catch. The car would frequently stop working whenever it was driven over railroad tracks.
Hold on, what? Railroad tracks? What does that have to do with anything?
Well, this is where Dan Winter's ideas come back into play. He suggests that the steel in railroad tracks disrupts the flow of imploding charge, preventing the device from conditioning the space properly.
Conditioning the space. Okay, now I'm really curious. What exactly does that mean? It's like the environment itself needs to be in harmony with the device for it to really work.
That's a really interesting way to put it. And yeah, it speaks to the importance of understanding the energetic dynamics at play. You know, not just focusing on the device in isolation.
It's like trying to play a guitar that's out of tune. You might be able to make some noise, but it's not going to sound quite right.
Exactly. You need that resonance, that harmony between the instrument and the musician.
And in this case, the instrument is the device and the musician is the environment. A perfect analogy. And speaking of creating that harmony, let's look at another example. The SAFE device, developed by Maxwell Chikumbutso in South Africa.
Okay, the SAFE device.
Yeah.
What's the story with that one?
Well, it was reportedly tested by engineers from Procter & Gamble, and they found it to be over unity.
Over unity. So, again, we're talking about producing more energy than you put in.
That's the claim, and it's pretty mind-boggling, right?
Yeah, it is. But are we any closer to understanding how these things actually work?
That's the real challenge, and Dan Winter argues that we've been asking the wrong questions.
Oh, yeah.
He says instead of just trying to prove or disprove whether a device works, we need to understand the principles behind its operation.
So what is the principle behind the SAFE device? How does it supposedly achieve over unity?
It all comes down to how the batteries are used.
Batteries. Okay, so it's not like a traditional generator or anything.
Nope. The SAFE device utilizes what's called inverse capacitance in the batteries.
Inverse capacitance, huh? I'm not sure I follow.
Think of a regular capacitor as something that stores electrical energy.
Right, like a little reservoir.
Exactly. But with inverse capacitance, you're essentially flipping that concept on its head.
So instead of storing energy, it's releasing it.
Not quite releasing it so much as drawing it in from the surrounding environment.
So the batteries are acting like antennas pulling energy from the vacuum.
That's a great way to think about it. And this idea of inverse capacitance is something that pops up in other over-unity claims, too, like the work of John Bedini.
John Bedini. Who's that?
He developed a system for over-unity battery charging, also based on the idea that batteries can become part of a resonant circuit that taps into the zero-point energy field.
Wait, are you telling me there might be a way to charge batteries without plugging them in?
That's the claim, and it's pretty wild stuff. Think about the implications.
I am, and it's kind of blowing my mind. Imagine electric cars that never need to be plugged in or phones that charge themselves.
It's a tantalizing possibility, for sure.
Yeah, but as with all these devices, there are challenges, right?
Absolutely. Stability and reproducibility are big hurdles.
Meaning?
Well, it's one thing to demonstrate over-unity in a lab setting, but getting these devices to work consistently in the real world is another story altogether.
Right, we've already seen how environmental factors can influence these things.
Exactly. And that brings us to another intriguing example that's actually commercially available. The Infinity SAV device developed in South Korea.
Commercially available. Wow, so people can actually buy this thing.
They can, but Dan Winter points out that it, too, faces limitations when it comes to stability.
So even if you had the device, it might not work reliably in every location.
That seems to be a recurring theme with these zero-point energy devices.
Which, again, highlights the need to understand the energetic dynamics of the environment, right?
Absolutely. It's not just about the technology itself, it's about the interplay between the technology and its surroundings.
Okay, I'm starting to get the bigger picture here. This is about so much more than just building a machine.
You got it. It's about understanding the fundamental nature of energy and how it interacts with matter, consciousness, and the very fabric of reality.
This is all incredibly fascinating, but I have to admit it's also a bit overwhelming. We're talking about challenging some pretty fundamental concepts of physics here.
It's a journey into uncharted territory, for sure.
Speaking of uncharted territory, I'm reminded of Elizabeth Donovan's work on transmutation.
Ah, yes. Elizabeth's research is truly groundbreaking. She's taking this whole concept of manipulating energy to a whole new level.
Transmutation. Okay, remind me what that is again.
It's basically the process of transforming one element into another.
Like turning lead into gold. Is that even possible?
It might sound like alchemy, but Elizabeth has actually developed sophisticated equations that calculate the specific frequencies and temperatures required for what are called isotope transitions.
Isotope transitions. Can you break that down a bit?
Sure. Think of isotopes as variations of the same element, like carbon-12 and carbon-14. They're both carbon, but they have a different number of neutrons.
Okay, I vaguely remember that from high school chemistry.
So Elizabeth's work focuses on using precise frequencies and temperatures to essentially nudge one isotope into becoming another, literally changing the structure of matter.
Wow, so we're not just talking about generating energy here. We're talking about actually manipulating the building blocks of the universe.
That's the potential power of this technology, and it's why Dan Winter is so passionate about making these principles accessible to everyone.
But if this technology is so powerful, why isn't it more widely known and utilized?
That's a great question, and it's one that a lot of people are asking. Is it simply that we're not ready for it yet? Or are there forces at play that are preventing it from becoming mainstream?
It makes you wonder, what would the world look like if we could harness this limitless energy source? What new possibilities would it unlock?
It's a tantalizing thought to imagine a world without fossil fuels, without energy scarcity.
It sounds almost utopian. But I suppose there are potential risks to consider as well, right?
Of course. With any technology this powerful, there's always the potential for misuse or unintended consequences.
It's a double-edged sword. This is all so much to process, but I'm definitely eager to keep exploring these ideas.
I hear you. It's definitely a rabbit hole that's worth going down.
Well, before we completely lose ourselves in the quantum form, I want to circle back to something you mentioned earlier. The idea that the vacuum itself is not empty.
Oh, yeah. That's a fundamental concept that really challenges our conventional understanding of reality, doesn't it?
It does. I mean, we tend to think of empty space as well, empty. But you're saying it's actually teeming with energy.
It is, and it's not just some fringe theory. You know, physicist Shinichi Seike, who's done a lot of work in this area, calculated the energy density of the vacuum to be something like 10 to the 93rd ergs per cubic centimeter.
10 to the 93rd. That's like a number with 93 zeros after it.
It is. It's basically saying that empty space is anything but empty. It's packed with potential energy, more than we can even fathom.
It's hard to wrap my head around that. So how do we even begin to make sense of that? How can something be empty and yet full of energy at the same time?
It's a great question, and Dan Winter uses a really interesting analogy from Eastern philosophy to illustrate it. He talks about the concept of Maya, the idea that the physical world we experience is kind of like an illusion.
So we're not really seeing the true nature of reality.
That's the suggestion. He compares the material world to, say, a tiny ripple on the surface of a vast ocean of energy. We're focused on that ripple, that little disturbance, but we're missing the bigger picture, the incredible depth and energy beneath the surface.
So we're like little boats bobbing around, totally oblivious to this massive ocean of energy all around us.
Exactly. And then the question becomes, well, what if we could tap into that ocean?
That's a pretty mind-blowing possibility.
Yeah.
But if it's all around us, why is it so hard to access? Why haven't we cracked this already?
Well, that's where the real challenge lies. Elizabeth Donovan talks about the need to disconnect charge from mass, which is a pretty radical concept.
Disconnect charge from mass. What does that even mean?
It's about separating the energy that makes up matter from the physical particles themselves. It's like, imagine being able to access the pure energy of an electron without needing the electron itself.
Okay, now we're getting into some seriously advanced physics.
Mm-hmm.
But I'm starting to see how this connects to some of the devices we talked about earlier, like the Tesla switch and these over-unity effects.
Absolutely. It all comes back to understanding the electrical nature of reality. Dan Winter argues that our current scientific models, which focus so heavily on gravity and electromagnetism, are missing a big piece of the puzzle.
So there's a whole other dimension to reality that we're just not seeing.
It seems that way, and it's a dimension that's intimately connected to consciousness, to the flow of energy, to how we experience and interact with the world.
This is making my head spin a little bit, but it's also incredibly exciting. I mean, we could actually learn how to work with this energy. The possibilities would be endless.
They would be. We could revolutionize our energy systems, transform our relationship with matter, maybe even transcend the limitations of our current physical reality.
This has been an incredible deep dive. We've covered so much ground today, from the theoretical foundations of zero-point energy to some truly mind-blowing examples of devices and phenomena that suggest it's more than just science fiction.
It's clear that there's still so much to learn, but the potential is truly enormous. If we can crack this, it could reshape our world in ways we can't even imagine.
Absolutely. So as we wrap things up, I want to leave our listeners with a final thought. If zero-point energy is real, if this limitless source of energy is truly accessible, what does that mean for the future of humanity? What new possibilities will it unlock? What challenges will we face? These are questions worth pondering as we continue to explore this fascinating and potentially revolutionary field. Thanks for joining us on this incredible journey, and until next time, keep exploring, keep questioning, and keep your minds open to the infinite possibilities that lie ahead.